Hi everyone, today in Integrated Math 2 we're going to be going over Chapter 2, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over a couple of the key concepts. Quadratic functions are when we have that f of x is equal to x squared. These are going to give us those parabolas. They look like the U's. And the standard form could be f of x is equal to ax squared plus bx plus c. And like I said, it's called a parabola. Axis of symmetry will be when x is equal to negative b divided by 2a. The y-intercept is c. Alright, so let's just go over those terms, a couple of those terms. The axis of symmetry is this red line. Notice it divides it evenly across both sides. Alright, let's also go to maximum and minimum values. So the graph of f of x is equal to ax squared plus bx plus c. And notice it says where a cannot equal 0. This is very important. So if it opens upward, it has a minimum value of a greater than 0. And if it opens downward, it has a maximum value of a less than 0. The range of the quadratic function is all real numbers greater than or equal to the minimum, or all real numbers less than or equal to the maximum. So minimum, maximum. Alright, so let's go over the steps real quick. Step 1 would be to find the equation of the axis of symmetry. Step 2, find the vertex and determine whether it is a maximum or minimum. Step 3, find the y-intercept. Step 4, use symmetry and find potential points on the graph if necessary. And step 5, connect the points with a smooth curve. Alright, so let's try example 1. We want to consider f of x is equal to x squared plus 6x plus 5. And we want to determine whether the function has a maximum or a minimum value. So let me write our question out again. So I'm going to say f of x is equal to x squared plus 6x plus 5. And the first thing I want to do is label which one's A, B, and C. So remember, if there is no number in front of a variable, we can always say it's 1. There's that invisible 1. And in this case, A is equal to 1. Our B is going to be our second term. In this case, it would be 6. And our C will be our constant always, which is 5. Alright, so in order to determine if we have a maximum or a minimum value, we can see first of all that A is equal to 1. And that means it is a positive number, because 1 is. And then we know the graph opens up. And because of that, we know we have a minimum value. Alright, with the same equation, let's state the maximum or minimum value of each of the functions. So like we said before, we have A, which is equal to 1, B, which is equal to 6, and C, which is equal to 5. And in order to find our minimum value, this is what we found out we have a minimum value. What we need to do is we need to use a special formula, which is minus B divided by 2a. This will help determine what exactly is the minimum value. And if you had a maximum, it would help you do the same thing. But in this case, we have a minimum value. So we have minus, and we're replacing with the letters that we already know, 6 divided by 2 times a, which is 1. Negative 6 divided by 2 is equal to negative 3. But we're not done yet. We have our equation f of x, which is equal to x squared plus 6x plus 5. Now let's replace all of our x's with negative 3. So f of negative 3 is equal to negative 3 squared plus 6 times negative 3 plus 5. And this is where our order of operations comes in handy. Negative 3 times negative 3 is 9 plus 6 times negative 3, negative 18 plus 5. And that'll give us actually negative 4. So f of negative 3. And then that is equal to negative 4. So our minimum value is actually going to be negative 4. So with the same problem, we want to state the domain and range of the function. So in this case, if we look back to a couple slides before, this is how I'm getting this information. So this one right here. So the domain is going to be all real numbers. And that's because there's no limit to our x values. Our range is going to be a little different. We found our minimum value to be negative 4, and that's going to help us determine our range. So our y, because range is y, must be greater than or equal to 4. Negative 4. And there we go.